Okay, next up is something called colligative properties, and we're going to be dealing with electrolytes and non-electrolytes. So this is the last part of the solutions unit. And we look at the behavior of solutions that, again, are called electrolytes or non-electrolytes, and some of the properties that these types of solutions would have. So first we want to do is take a look at this. And again, the word colligative properties we'll get to in the next video, but I just want to introduce just the concept of electrolytes and non-electrolytes, a really important thing moving forward. So what we want to do is look at these types of compounds and realize that what an electrolyte is simply a solution that has dissolved ions in it. Okay, and again, these dissolved ions, okay, are mobile and they're going to be moving. Okay, and they have the ability to conduct an electrical current. And a lot of times, electrolytes, what we think of is, the first thing that comes to your mind, because it's just a brilliant marketing scheme, is Gatorade. I mean, we always think of Gatorade commercials of having electrolytes in them. We always hear this. Or we hear when people are dehydrated or they play a lot of sports, they lose their electrolytes, or electrolytes are lost out of the system. And typically, that would be sodium and potassium. That's important for the body working properly, muscle contraction, and just general, blood flow and feeling good. A lot of times has to do with your electrolytes and the nerve impulses. Okay, so important to know. So movement of dissolved ions. Okay, so that's important. Okay, the ions must be freely moving and soluble. Okay, so that's important to know that you want to make sure these ions are soluble. They got to be able to dissolve and break away from their solid state. Okay, so three types of electrolytes. Something important you're going to have to know going forward. So you're going to have to be able to recognize these compounds. Okay, and the first one's called an acid. An acid basically has a hydrogen ion in its formula, usually listed first. Okay, and that's going to be an H and any negative ion that would be attached to. So good examples are HCl, H2SO4, HCl. So you see the H's that are in front of these typically would be acids. Okay, and we're also missing one from this, and that would be anything with a COO. So CH3COOH. Okay, so this is the positive here. You also see the COO at the end of this would also be an acid. It doesn't really matter what's in the beginning. It's just the acid in a COO. Okay, number two would be something called a base. And a base is going to have a metal, or it's a positive charge, a metal, that also has a hydroxide ion in it. Okay, and again, as long as you have any metal plus a hydroxide, and that would be soluble, that would be a base. The many different types of bases would be maybe sodium hydroxide and potassium hydroxide, calcium hydroxide. Again, these would be, you'd find these bases in table L. You'd find the acids in table K. Table K would be acids. Table L would be your bases. All right, so you want to be able to recognize an acid base when you see it. Okay, next are salts. Okay, salts are soluble ionic compounds. Okay, soluble ionic compounds. Okay, and again, you'll find these in table F. Okay, again, calcium and chloride, sodium nitrate, ammonium bromide. These are salts. These are ionic compounds that are soluble. Again, they would also be electrolytes. So acids, bases, and salts. Okay, and important to know that these groups of chemicals, these groups of compounds, when they dissolve in water, will produce mobile dissolved ions and hence will be electrolytes. Okay, some non-electrolytes. And now non-electrolytes are similar to electrolytes in the fact that they must dissolve. All right, so considering they must dissolve, they're going to be polar molecules that dissolve. So they have very similar polarity to water, but they do not ionize, or they do not break up into ions. Their molecules remain intact. Okay, so molecules remain intact. They do not form ions. Okay, and there is no electrical conductivity, hence the name non-electrolyte. I guess they couldn't come up with a better name for a non-electrolyte, so they just called it a non-electrolyte. All right, so it's important, again, you want to make sure you know these compounds. Okay, number one is alcohols. Okay, alcohols, a good example is methanol. You'll see the C has to be covalently bonded to the OH. Okay, now don't confuse alcohols with bases. You'll see the difference where this is carbon NOH versus a base would have a metal NOH. All right, again, it's easy. These are very, very easily confused. So you want to be careful with this. All right, and sugars too. Okay, sugars, C6H12O6 is good. You could maybe want to add C12 H22O11, which is also sucrose. Okay, so glucose and sucrose, okay, and alcohols. Please don't confuse. Don't think bases. Okay, so important to know. You cannot confuse those with bases. So alcohols and sugars, really important. All right. All right, so just a little ideas about these electrolytes, a little picture for you. Okay, so again, think about a non-electrolyte as far as now. This is called a conductivity tester, and what a conductivity tester would do is if you plug it into the wall, you would have electrons going this way and being pulled back in that direction. So if I check my pen here, really quick, my pen color would be black. So you'd be pumping electrons in that way and pulling electrons through back here. All right. So what would happen in an electrolyte is you'd have these molecules that are non-electrolytes. There's no ions. These are intact molecules, and these intact molecules are not attracted to either side of these plates that would allow you to conduct the current. So basically, you do not light the light bulb in this case. The light bulb will not light because you do not have any electrical current. So because of that, you're not going to have electrons flow through here. Nothing will happen to complete the flow, and you'll have no electron flow. However, a strong electrolyte, if you notice in here, you would have ions that are plus and minus. And these ions, the positive ions would travel to the negative plate. The negative ions will travel to the positive plate and release their electrons. So electrons would be forced to go back this way, and they would be allowed to be picked up going this way. And that would be allowed to go. And now this light bulb will actually will brightly light because electrons will flow through the light bulb and back. Okay, so you're allowing the conductivity of these ions in the solution. Now, in the case of a weak electrolyte, that would be a combination of maybe some molecules and some ions. If you have few ions, okay, so this would be many ions. If you had very few ions, you might have maybe just a little bit of current through here, okay, a lot less, okay, and you would light the light bulb dimly. You could see the difference between the light of this. So again, this is just a little visual to show you how you would show with a conductivity tester that the solution is actually conducting or not. Now again, it's not powering the light bulb. The electron flow is coming from the wall here, or this plug, but this is showing that electrons are flowing through by looking at the light as a tester. All right, so really important. Here's some Gatorade. Again, a little bit about Gatorade. Gatorade contains sugar. That's why it's sweet. It contains sugar as well as sodium citrate and some potassium citrate. The citrate gives you that lemon lime kind of tangy flavor to it. But the sodium and positive ions, actually the ones that are goes into your body or replaces the water, and the sugar gives you a little energy, but the sodium and potassium replace the electrolytes that are in your blood and that are responsible for nerve signals. So again, cramping could be reduced by this. Again, you sweat. I know it's gross, but your sweat tastes salty a lot of times because you're losing those salts. So this will replace that during intense exercise. And I think a great way to remember this is to say if you're working out and you're drinking Gatorade, you're going to get good abs. And what does abs stand for? Acids, bases, and salts. Right? Great way to remember this. I have to give credit to a student a number of years ago who said that if you drink Gatorade and you work out, you get good abs. Acid, bases, and salts. Acid, bases, and salts are your electrolytes. So you want to remember that. So kudos to that kid for remembering that. All right. So we take this idea and we take it a little further and we look at the breakup. What actually do you break up when you break up electrolytes and non-electrolytes? So let's take a look at a couple of reactions in this really quickly. Okay, electrolytes. Let's look at a few examples of breaking up. So again, HCl, that's an example of an acid. Okay, because I have the H in front. How does that break up? Well, HCl breaks up into what two ions? H plus Cl minus. Now again, one thing is breaking up to 1 and 1. So really, there's two ions that are here. Okay, so two ions, there's two pieces. Okay, two pieces are going to have the symbol I. So you have two ions. Look at calcium bromide. That is a metal and a nonmetal. That's called a salt, right? So we're going to break that up. We're going to take calcium and bromine, and we're going to break it up completely into its ions. Calcium has 2 plus. Now, here we're going to get to bromine, but remember, we're breaking up into all of the ions. So we're going to have 2 times bromine for a total of 3 ions, right? We're going to have 1 ion plus 2 ions makes 3 ions. We'll have 3 particles, okay? Aluminum nitrate, again, a metal and a polyatomic ion is an ionic compound. What are we breaking up into? We're going to break them into aluminum, 3 plus. Again, I'm getting these charges from the periodic table, okay? And nitrate. Nitrate, we know, is a polyatomic ion with a negative charge. You should know that still. Or if not, you got to review it. But however, we have 3 nitrate particles here. We need to have 3 nitrate particles there. So 1 plus 3 is 4 ions. Okay, so every time we have one of these, we get 2 of these. Every time we get one of these, we get 3 ions. Every time we get one of these, we get 4 ions. Very important to know, okay, how many ions you're getting. We're going to need this information later on. Okay, so electrolytes are breaking up into the ions you can see. Okay, now, so I becomes the total number of ions contained in the formula of the electrolyte in 1 mole of formula. So again, you can probably see it here. 1, you can see here there's 3, 1 calcium and 2, and then 1 and 3 is 4. Okay, important to know. All right, now in a non-electrolyte, we talked about the fact that they don't break up into ions because they don't have ions. Okay, so really important to know. Here is an alcohol. Okay, that's a C plus an OH. So we would have CH3OH. If we were to dissolve that in water, and again, all of this is AQ, guys. Make sure you remember all of this is AQ. When these guys break up, you're going to break up into AQ all the time. Okay, this is going to break up into liquid form. It's going to break up into, you guessed it, it doesn't break up. It stays together as alcohol. So you're going to get 1 molecule, 1 piece. 1 breaks into 1. Okay, C6H12O6. You take a certain amount of glucose as a solid, you dissolve it in water, and what does you get? You get glucose as AQ. It does not break up that glucose molecules together, it stays in 1 piece. Okay, sucrose, C12H22O11 as a solid. Yes, that's going to break up into C12H22O11. You guessed it, AQ. We can go on all day like this. 1 particle. So again, both of these are going to be your sugars. Okay? And so I, the number of particles represented by the variable I, is always 1 for non-electrolytes because the molecules stay together as 1 mole. So 1 mole makes 1 mole, and 1 mole makes 1 mole, and 1 mole stays as 1 mole. Okay? So you would not conduct electricity here because there's no ions, but you would conduct electricity here. The attention is paid to these electrolytes. They're going to be different for each formula. Okay? So this is the end of this little mini lesson in the beginning, just to analyze what an electrolyte is and what it is, and I'd be able to identify it. You need to be able to identify it before we take the next step. So take your time doing this, okay, and make sure you can go through it. Again, check your packet and what we do in class. All right, have a great day, and we'll see you in the next one.